Okay, so people did well with this, substituted correctly, and most of the algebra I saw looked good, and a lot of you did it very quickly. Okay, that's very good. Very good. Yeah, usually people are pretty good with linear functions. That doesn't take away from the fact that most of you people are pretty good about doing that. Okay. This one is a little trickier because you're not used to thinking this way. This illustrates things about the fundamental toolkit functions we use for the whole course. And actually for almost all the functions that you build in undergraduate mathematics. You're going to learn how to build them in this course. You won't learn everything about how to analyze them. You can take calculus, you learn more about how to analyze and then get into theoretical analysis, all that stuff. Okay. But the functions that you use, the functions we use to model things in the real world. I think I mentioned business applications last time in the rocket. Okay. Those are right there. Optimizing your profit with a quadratic function. It's the same shape as this one. Assuming that I've drawn this one a little more accurately. Okay. So we go twice as close to the y-axis. Well, it helps to just draw a dotted line. And then another line twice as close to the y-axis. In other words, halfway to the y-axis. Twice as close as halfway to, right? And then we get twice as far from the x-axis. Well, how far were we from the x-axis? I could actually draw out lines here. Although most of you did pretty well with that part. So this line, well, this line is supposed to be twice as far from the x-axis as this line. I didn't get that quite right. So you'll be able to locate a point. Well, that wasn't hard. We can do that again. We should go twice as close to the y-axis. That's going to put us on a line here. And we can go twice as far from the x-axis. We're this far, and now we're going to be like this far. The x-axis. Making sense? Okay. And we should do it again. We're not going to have to do it too many times, because every time you double the distance you go gets bigger. I can do this once more, and maybe once more after that, and then I'm done. But if I had a higher graph, well, we want to think about what we're doing. Okay, so I go twice this far. That puts me here. Graph is getting steep. Notice that? You can look at your own graph. Probably doing the same thing. Most of you got pretty good looking graph. You did, it's getting kind of hard to squeeze these things in. Even chalk is like, well, that's going to be pretty much at the top of this page. Okay. Now, there's a set of points. Most of your graphs look sort of similar to that. You have to be able to estimate halfway and twice as much. And I'm not going to test you on how well you estimate it, but if one of your intervals is this long and another interval that's supposed to be the same as this long, then I'm going to have to say you got to get a little better with that. Okay. I mean, mine aren't precise. To measure these is probably at least a 10% difference in some. But that's okay. You get the idea of the graph. Right? What's happening with this graph? How long is it going to take me to get to the y-axis? Let's talk about this for a minute. Okay, so as I said, my idea of doing it this way is absolutely brilliant. I'm going to go viral. We're all going to be famous. Okay, but nobody's going to be able to recognize what's got my mask on. Okay. Now, so here we are, and I ask a question. How long will it take us to get to the y-axis? Answer I got was never, it never happened. Because you're always going halfway. You still got always a halfway to go, no matter how small, how close you are, you can still go closer. That's a really important idea. And I don't know how well people are prepared to understand that idea. Okay, so let's clear this up here. We got cops and mentioned. Okay, it also interferes with my hearing aids less because when I put it on, the go my hearing aid popped out. You know, some thousands of dollars. So it's one reason I hate masks, but doesn't mean you shouldn't wear them when the CDC says we need to wear them. Okay, I'm not saying. So there it is. We never get to the y-axis. So my other question, how high do we go? What's the highest we can get? And the answer I got was infinite. Well, infinite isn't really a height technically, but that's the answer. As I said, but I explained. Okay. But what I'll say is there's no limit to how high. Okay. So I can say two things. That's a pretty important idea. There's no limit to how close we get to the y-axis. Hope everybody understands that and kind of remembers that idea. And no limit to how high we go. Okay. SMS, I should say, but I'm not able to write that. Okay. I'll say this. It starts with the same letter I started to write. That describes an asymptote. There's one more thing about an asymptote. The thing keeps getting bigger as you approach the y-axis. It never gets smaller. Okay. So it keeps getting bigger and there's no limit to how big, no limit to how close. That's an asymptote. And you can imagine, if you had a football field, okay, and a big scale, you put several more points on it. But by the time you did, let's see, 10 more points, you'd be off the football field. Because the distance keeps doubling, right? Okay, so there's an asymptote. Now we can describe that algebraically, but this is easier to understand. It's more hands-on, it's more visceral, it's more a lot of things. Probably a lot of words that I don't even know to describe what it is. Even though I could probably make up words, because when this goes viral, everybody's going to pick up my vocabulary. Okay, well, there it is. Okay, now we could have done the same thing. I didn't specify that we should stay on the same side of the x-axis, did I? So we could have gone one here and one here and one here, one way down here. We could have had another branch of this function or of this process. Okay. Okay, so this is like a main branch. And this is like I didn't mess something up here. Remember my word, secondary branch. There are two other secondary branches. Some people actually drew points on the to the left because this point here, which is just kind of a reflection of this point, is also twice as close as this point was. Right? It's twice as close as on the other side, but still twice as close. We talked about that a little bit last time. And then you have a point here, and a point here, a point up here, and do this sort of thing. Okay? And if you include the first point, here, have a reflection of this, it's like a curve again. Okay. And then you could also do the same thing. Is this graph ever going to touch the y-axis? Nope. So there's no point for the y-axis. Okay. Okay, this is a secondary branch. We would also call this a secondary branch. And we would call, I don't know how to draw an arrow. This thing is a secondary branch. Okay. We got three secondary branches. We don't call them secondary, tertiary, and whatever Fourier is. Okay. We call them all secondary branches because each one is as valid as the other one. We do choose the first quadrant as the main branch, but we could have chosen any quadrant as the main branch. The others would be secondary. We're thinking about it. And it's going to have applications to properties of the toolkit functions, which I'm going to start talking about very shortly. I will say then, matter of fact, I'm going to talk about it like that. This there's your main branch. I'm going to say something else. The graph I have here isn't a function. What's a function? Well, I ask you, when x takes this value, what value does y take? What's the point on the graph that has that x coordinate? Well, the graph as I've drawn it, there's a point up here that has this value of y. There's a point down here that has this opposite value of y, right? Two values. A function can't have two values. For given x, you can only have one block because we want to ask, like, how high is that rocket going to be after 10 seconds? You say, well, it's 1,200 feet according to the graph. Okay. If you do the whole parabola, this whole thing, if this somehow represents the rocket, okay, if you ask the question, well, yeah, it still works, okay? So like I said, I started saying, okay, so back over here. So here's your main branch. If you want a function, you have a blue function. This is a function because now I don't go this part of the graph. I stay on the blue. If I stay on the blue, I can always tell you what the value of y is if you give me a value of x. Except you can't give me a value of 0. We've seen more. Okay. I haven't even given you the formula for this thing. You haven't had to do any algebra. Okay. I'm going to say the blue function is called f of x. How many of you seen f of x notation? How many of you have it? I have to explain it to you a little bit, but that's something you really, we kind of assume you know, but you're going to have an assignment that tells you. Okay. You can also look at what I did, at least briefly, in the MDE 61 class. A little while ago. Okay. And we're going to have the green function. Oh, G of X. Yeah, if you're not familiar with the notation, don't know why we want to do that, except I've got to call them something. So now I've got names for them. Okay. Okay, well, now that I've named my function already. I ask you to do something. I'm going to say that the coordinates of this point, okay? Color. Have abbreviated coordinates. Coordinates at this point, I'm going to say are 64. Really get everybody's numbers in the top. Look at what somebody else is doing, figure it out for themselves. I'll explain it in a minute. I'm going to say that's 64. 4. Coordinates of this point. Now what I want to know is, what are the coordinates of each of these points that you graph? So on the paper, indicate what those coordinates are. If you don't have room, if your graph is too small, you can just list the coordinates. I'll know what I'm looking at, okay? So let's start with the question. You want to start with the first question, which is, if this is 64, 4, then what are the coordinates of this point? What's the X coordinate and what's the Y coordinate? If you can answer that, then you can probably answer the rest of them. What you think about it? Okay, that's good. 128 would be out here. That's what's close. You can break this down into 2 questions. What's the X coordinate of that first point? And then what's the Y coordinate? You know what the rule is for locating the points. You should be able to figure out the X and the Y coordinate, but if not, I'll clarify for you. Okay, 56. What is it? If you list the points in order as you go closer, then I'll be able to tell which point. Yeah, one of them definitely be 256. Okay, so say that this point is 64, 4. Now this point is twice as close to the y-axis, so what's its x? And it's twice as far from the x-axis, so what's its y coordinate? Okay, just answer those 2 questions. Good, you got at least one more point on there. Not when you drew this. You got a little careless. This point is not twice as far from the x-axis, although it's twice as close to the y-axis. You do that.
Okay.
Okay.
Thank you.
When you calculate its coordinates, it'll make more sense. to have it.
Okay.
Okay, well. Okay. But I think you got the right idea. So you should be able to list the rest. You got the pattern. I think you should be able to get the rest of them. Was if the X score, the wild card was always marked. There's your correct. I can see what you were thinking, but it's too far.
What's that one, yes?
That looks good.
It wasn't
16 looks
32.
good.
It wasn't 32, then it was 16.
Yeah, well, listen, this was, actually haven't written out clearly, but I think you see that. Looks good. A minute, I was looking at these fractions, I think Josh is also wanting to know that. Okay. Okay, you got four of them. No, you didn't really go twice. So you should. Because it wants to be way up here. And make sure, you know, you sketch this out accurately, you really give yourself the right idea about how this is going. Okay. Okay. I think we're looking pretty good on this. Okay. So for the moment, I'm just going to draw this in the first quadrant. If I take any point here, I'll do this. Twice as high, and then I go half way, and go twice as high again, and I go halfway, twice as high as that, and go halfway, and go twice as high as that. Unfortunately, I started close enough to the top of the board that I don't have to do any more. Okay. So here's a couple of. And this point is 64.4. Yeah, okay, involved here. Basically similar to farm. I'm kind of wanting to call this f of x, but I've already called this function f of x, right? Basic reciprocal function is going to be, I'm going to call it r of x equals 1 over x. That's talking too loud. What he's saying, I think it's pretty interesting. Pretty soon I'll be writing down what he said, because I don't have no filter. Okay. The multiple of this function. Okay. Now, let's just talk about this function. I'm not going to explain what we do with this until we graph it. And this time we're going to graph it based on a table and some arithmetic. I mean, you've already done plenty of arithmetic, just taking halves and joining and all that stuff. Okay, so here we've got x and r of x. X values are -2, -1, -1/2, 0, 1/2, 1, and 2. And what I'd like to do is have you calculate what r of x is. Well, I'm going to give you an example because not everybody has done a lot of function notation. Okay, so x is -2, and what do you know about r of x? How would you rewrite r of x if you know that x is -2? Well, you'd write that. It's just plain old r of -2, right? Because if x is -2, you replace x by -2. Okay, so r of x would equal r of -2. And you have the rule, r of x is 1 over x. So we can look at r of -2 is, by writing r of -2, I've declared that x is for the moment -2. If x is -2, then 1 over x is 1 over -2, isn't it? What's 1 over -2? 1, -1/2. And that, sorry, yeah, -1/2. So now I can put my r of x value in here. Okay. Do you understand what we just did? Okay. So I can abbreviate all this by just saying, if we're going to say y equals, so y is going to equal r of x. So let's put it this way, y equals r of -2, which is -1/2. So that's why we put the -1/2. Now I have a point that I can put on a graph of this function. Well, let's start with this value and ask you to calculate r for each of these values. I'll come around here after I'll get started. You might not be very familiar with this notation. Okay, so I'll start by doing, go ahead and copy down the table. Here y will equal r of 2, which equals 1. And you should write out the details like I did here, just to get used to the function notation and remind yourself what it means. So give yourself space to write out some details, see what you can do. Look up your shoulder. Oh, yeah. Y'all did pretty well. There's a couple of mistakes that I often see, and you rewarded me by making, so I have something to do and I don't feel as useless as usual. Okay. So why is R2? Well, that equals 1/2 and kind of done. And here, R1 is 1/1 because if X is 1, X has to be 1. That's the first thing you got to understand about function notation. And I will say that most pre-calculus groups have more trouble with that than you all have. That's just making me cautiously optimistic. So, okay. And then 1/2. Now this can be a little tricky for people. I'm not sure we did the exercise in fractions. I thought we had done. Thought I decided to. I think maybe it was the exponents, maybe do tonight, something like that. Okay. I mucked around with these last night about 4 a.m. So, I don't remember which world I was in at 4 a.m., but I was mucking around with this stuff. Okay, anyhow, okay. Now, let's write R1 half out here. Okay. Now, what is 1/1/2? Use your calculator, but I don't want you to use your calculator. I want you to understand why the result is what it is and how it relates to what we did over here. Okay. First of all, 1/1/2 means 1 divided by 1/2. Okay. Okay, I asked for the rule of multiplying fractions, got an instant answer, you multiply by the reciprocal. That's 1 times 2/1. Okay. Of course, 1 times anything is just that thing, so that equals 2/1. And dividing by 1, you still get whatever you're dividing into. Okay. So there may be more steps than necessary, but little Larry is skipping too many steps at this stage. Looks like most of you can't, but okay. And what's R of -1/2? Well, it's 1/-1/2, which is 1 divided by -1/2. Okay. And when you divide by a negative, you get a negative. So that's a negative of 1 divided by 1/2, which is -2. So you get -2 here, you get -1 here. Now this 0 thing. Get R0 equals 1/0. You might remember the rule for that. Some of you wrote it down. But let's see why the rule is so that you don't forget the rule. What's 10 divided by 2? Show me with your fingers. Okay. Because we've got the camera on here. Okay. Okay. Count to 10 by 2s using your fingers. 2, 4, 6, 8, 10. What did you get? Okay, so your fingers tell you what division means. Okay. 10 divided by 2 is 5, because if you count on your fingers, that's how many it takes. They don't want to divide 11 because then you have to cut a finger in half. That's painful. And somewhat the same. Okay, so we're not going to do that. Or maybe you could just, divide into 11. Okay, there's half. All right. Okay, so what's 1 divided by 0.2? Can you count to 1 by 0.2? 0.2, 0.4, 0.6, 0.8, 1. 5 again, right? Well, what would 1 divided by 0.1 be? Show me with your fingers what you think you're going to get. Yeah. If you count to 1 by 0.1s, it's like how many dimes are there in a dollar? You ever seen a dime? You ever seen coins? Okay, they're getting rare. Okay, makes sense. Now, I want everybody to count to 1 by zeros using their fingers. That's it. I like that. Never seen anybody do that, and I'm going to use it forever. It's a wonderful addition to my viral fame. And I'll give you that's good. Okay. Yes. You never get there, right? So 1 divided by 0 makes no sense at all. We understand this? Okay, well, you probably memorize something that says that the answer is DNE, does not exist. Okay. I like AP, ain't possible. Matter of fact, even better than that, I like ain't possible. Okay. You can't do it. You don't have that many fingers. And they wouldn't do you any good if you did, because that doesn't exist. Okay? Get that in a head. Okay? So now if I want to graph this function, have no boards up here somewhere. Yeah. Okay, so now watch carefully. This is why I want you to construct these graphs. I'm going to put a point out here at an equal distance along here. I'm going to put another point. This will be -2 and this will be 2. Now, how am I going to construct a point for 1? Well, I can use compass and straight edge to do this. We can bisect a line segment. We're not going to do that. I don't trust you all with sharp things. So here's 2. And I cut this interval in half and I get 1. Cut this interval in half, I get 1. That's pretty good. Okay. And if I carefully cut the interval in half, I'm going to have a pretty even scale. So I'll get a pretty good picture of what the graph looks like. Okay, well, what next? Well, I've got now x values, -2, -1, 1, 2. 0 is easy, that's the origin, okay? And where's 1/2 and where's -1/2? I take this interval and I go halfway to the origin. Now, with my usual lack of foresight, I should have labeled these above the axis, I'm gonna actually do that. Let's see what. Because the numbers are better than the other graph. So this is 2, -2, negative sign. -1, -1/2. And then I'm gonna need y values that go from -2 to 2, don't I? I'm gonna need, don't I? I'm gonna need, ain't I? Okay, that's better. Gotta use proper English. Okay. So I'm gonna put 2 up here. And an equal distance down here, I'm gonna put -2. Then I'll have -1 here and 1 here, and 1/2 here and 1/2 here. I'm not gonna bother labeling those because I did the same thing here that I did there. Okay. Now I can go to my table. And -2, -1/2. That's going to be here. Thank you. There's -2, -1/2. Then we got -1, 1. And -1/2, -2. 3 points. Then we have 1/2, 2. Just draw these dotted lines. We call these projection lines. Keep myself honest and do this as accurately as I can. A piece of chalk on the board doing it. Okay. Now, do you see anything here that looks familiar? What's happening with these points? When I move twice as close, I move twice as high. Move twice as close, I move twice as high. Okay. So the 1/x function is much like the f of x function that we did. Okay. I should have made that blue because it isn't f of x. I'm going to. I'm going to draw. Okay. Now, if we continued pattern of these things, a geometric pattern, just the way the points move, they double every time you move twice as close to the y-axis. Okay. We know that this thing is going to just take off. It's going to take off down here. It's never going to touch the y-axis. Okay. So if you thought 1/0 was 0, you just touched the y-axis, didn't you? Okay, if your table had a 0 here, well, that gave us a point here, it's on the y-axis, doesn't fit anything else in the graph. It doesn't make a bit of sense. Okay. So don't feel badly about that. You know, half the people, more than half the people in typical pre-calculus class think 1/0 is 0. You think any number of the 0 power is 0. As soon as you see a 0, you think 0. Okay. Got to understand the rules. Okay. Now, this graph is good for a lot of things. And I'm not sure I'm going to have time to do an example, but I want to do a little more algebra with this. Okay. I want to prove, well, first of all, I'm going to say that f of x is a multiple of r of x. The graph has identically the same shape. Of course, f of x also has a branch over here. Remember when we constructed it, see with the blue, there's an f of x function. It has exactly the same shape as the R of X function. Except if you graph them both on the same scale, f of X is going to be stretched out this way because the y numbers are a lot bigger. So first statement you want to understand, I'm asserting this, I haven't proven it, saying f of X is a multiple of R of X. So f of X equals a times R of X. Note that a doesn't have backward apostrophes on it. It's not your a. So don't try to hog it. Okay. A is just some number. We don't know what the number is yet. I don't even know what the number is yet. I haven't worked it out. But it's really easy to work out. Okay. If f of X equals a times R of X, well, we know that f of 64 is 4, right? If f of X equals a times R of X, f of 64 I think I just did something really antiviral, really done, in other words. Let's stop this. Okay, I think I'm back on track. Something about that bothers me. But I think it's going to work out. Okay, if f of X is a times R of X, then f of 64 has to be a times R of 64, right? And what's R of 64? Well, R of X is 1 over X, right? R of X is 1 over X. So R of 64 would be 1 over 64. So that's a times 1 over 64. Now what's f of 64? Yeah, this is f of X. This is the point 64, 4. According to what I just declared, right? So this is 4. So what's the value of A? Write this down as an equation and see if you can solve it for A. Like what do you do to both sides? There's one step, one thing you do to both sides, and you're going to solve for A. Okay, now people haven't, I expect this, some people have trouble with this. Didn't expect practically everybody would have trouble with it. So I'm gonna write this up here. Okay, we're trying to solve for A, right? See any denominators in this problem? Which is a denominator, right? 64 is a denominator. General rule, if you have a denominator, you multiply both sides by the denominator. And that gets rid of all the denominators. Then you don't have denominators to confuse you. So what I'm just saying is it's okay. Well, 4 times 64 is easy. That's 256. What's 1 over 64 times 64? Yeah, and make sure you're using the right pen. Okay. Okay. Which one? Now, let's really show the details. One over 64 times 64 over 1. Well, if you multiply fractions, you're going to multiply numerators, multiply denominators. I don't like crossing things out because people cross things out wrong. I think I've mentioned that before, but might have been in the class. Okay. I don't like cancellation because very few people correctly understand the rules. The rules for cancellation are really harder than the rules of arithmetic. The cancellation is not a rule of arithmetic. It comes from the rules of arithmetic. Get a little prouder here. That's 64 over 64. And down here, this is a little sloppy. So A is 64. That makes sense? I'm going to say A is equal to 64. Okay. A is 56. Well, f of x is 256 over x. You can verify that because you have your values of f of x. You said, for example, that here the value of f of x should have been 16, right? And if this is 4, this is 2, and this is 1. I'm sorry, this is 4. This is 64. This is 32. This is 16, right? And this would be 16. Well, if x is 16, 16 into 256 is 16, isn't it? Well, you might not know that. So if you plug in the value of x for any of the points that you got, you're going to get the value that you got for f of x, okay? You're going to get the coordinates of your points. Okay. Now, if you understand all that, that's really something that gives you a picture that people usually don't get in a pre-calculus course. There's more to it, but I want you to review this and make sure you understand as much of this as you possibly can. There's a whole lot of pre-calculus, just in this one example. Okay. I might modify the assignment slightly, and if I do that, I'll do that within the next hour or two. So if I do, I'll email you. To alert you. If you do any of the things that are assigned, that's fine. You're gonna have to do them eventually, since you're working ahead. But never sure quite what we're gonna get done in class. Y'all did really, really well. Did you know? Yeah. Yeah, if you got to reply to it, that's it.